All right, here we go. So polynomial inequalities in one variable, and here's how we're going to do these. So looking at this here, it says g cubed minus 2g squared minus 3g is less than 0. And maybe as you're looking at it, you're thinking, I have no idea how to figure out where this is going to be less than 0. I got my g cubed, g squared, uh, and so here's one method for finding out what g values will make this polynomial inequality will give us solutions which will satisfy being less than 0. And so here's one method, and it's going to be to just pretend that this is equal to y, and what we're going to do is we're going to actually go ahead and just graph it as though it was less than y, uh, and see kind of what happens. And we'll see that sometimes the output is negative, sometimes the output is positive, but in those areas there, when we'll have less than or greater than 0. And so here we go. Kind of a long introduction, but let's factor this out. So I'm going to have g times g squared minus 2g minus 3, still less than 0. Uh, and that factors down to g times g minus 3 and g plus 1, still being less than 0. And remember, we're going to kind of think of it as being, instead of 0, think of it as y, because that will let us graph this. So I'm going to sketch a graph here, and this the graph itself is not the answer to the problem. It's just a tool to help us get there. It's a method right now. We're not saying that this is actually a graph because, again, it's actually less than 0. We're just looking for where on this graph we'll have negative numbers because those input will be our solutions. All right, so I've got a root of 0, a root of 3, and root of negative 1. So here's negative 1, 1, 2, here's 3. And if it were set equal to y, it head on up, have to turn, come back down, have to turn again, and head on towards positive infinity. Now, let's include our roots here. So negative 1, 0, 0, 0, and 3, 0. And what we're looking for is the output where that will satisfy this. And so where will my output be negative? And if we kind of break this graph up into some pieces here, it looks that if x is less than, or g rather, if g is less than negative 1, the output, or the y value, since we're pretending it's equal to y, is negative. So when will all of this be negative? Well, if we plug in a g value that is less than negative 1, that will give us a solution. And kind of let's run through and see that for a second. So if we were plugging in negative 2 cubed minus 2 times negative 2 squared minus 3 times negative 2, this should be less than 0. And let's find out. So negative 2 cubed, that's negative 8, minus, well, negative 2 squared, that's positive 4, and 4 times 2 is 8, so minus 8. And then minus, or rather plus 6. And is that less than 0? And again, it should be. Let's continue on. So we get negative 16 plus 6 is less than 0, and that's negative 10 is less than 0. And so when we plugged in the g value of negative 2, we found a true situation where negative 10 is less than 0. Okay, so there's those situations. And now, if we were to continue on our graph, between negative 1 and 0, again talking about the x or the g value, the input, here the graph is positive, or my output is positive. This is a positive range right here. Okay, so if we were to plug in negative 0.5, we would find out that this in fact would be false. We'd have something positive is less than 0, and that's not in fact true. So those are where we get false solutions. Continuing on, this whole range right here between 0 and 3, those g values, again, the output we get is negative. So those are solutions for us again. And then once we get past 3 as an input, then our output becomes positive again and is no longer less than 0. So back to positive again. So we go negative, positive, negative, positive. Think through it. If you had a double root, you'd have to be careful about that. It's not just always going to switch. Actually, look at where the the output itself is. And so we've got positive numbers, negative numbers, positive output, negative output. All right, now again, this is just a tool. This is not our solution. We need to actually write out when do we have g that satisfy this, this polynomial inequality. And so for the first part, anytime that g is less than -1, we're getting output that are negative. Okay, so here's again our solution. Where g is less than -1. We're not going to include the numbers from -1 to 0 because those give us positive output, or the roots themselves give us 0, and that it's not or equal to, so that won't satisfy this inequality. However, once we get to 0, then we'll start having solutions that satisfy the inequality again. So from 0, we want numbers that are greater than 0. So g is greater than 0, but g is also less than 3. So we're looking for just this range of x values right in here, just this range of x values. And that's our solution. So we use what's called a sign graph to solve the question, the inequality. Our solution isn't the graph itself. Our solution is right here. But we use that sign graph to see, hey, where are my values negative? Because we want to know where it was less than 0. Now, if we had done, if it had been where is this polynomial equality greater than 0, we'd be taking the positives, and we'd have a different answer here. Okay, but again, we're looking for the negatives where that was less than 0. Hope that helped.